Hey guys, welcome to another episode of Chemistry at the Home. Coming to you live from my casa. So, hope you're excited for this. I'm pretty excited for this. This is day 2 of concentration. Today we're talking about parts per million and parts per billion. So, to start this off, we're going to do a little review. Here are 3 questions that you should be able to answer at this time, but they are a little bit more complicated than some of the other questions we've given you. So, this is a story about Nave Nosrit, who just poured exactly 975 milliliters of H2O when, all of a sudden, Nabrib Hitims spills 25 milliliters of 3 molar HCl in the glass. 3 questions on the board. We want you to solve them. How many moles of HCl are in the glass? How many grams of HCl are in the glass? And then what is the molarity of the solution in the glass? So, this is the question. We want you to try and solve it as best you can. Go ahead and pause the video and solve these problems. Great, so hopefully you got a chance to solve them. Let's dive into it. Okay, so the first thing we notice here is that we notice that the 975 milliliters plus another 25 milliliters, that adds up to 1,000 milliliters, which is the same thing as 1 liter. So we're going to look to attack this problem first about moles of HCl, then we'll worry about grams, then we'll worry about molarity. So the liters part will come in with that last question. But the first question is, okay, how many moles of HCl do we have? So this is a little bit different for 2 reasons. The first reason is that we're working with milliliters, and remember, molarity, big capital M, is always in liters. So hopefully the first thing you did with these 2 milliliters numbers was convert them into liters so that we can actually use them. In terms of solving them, here's what I have on the board, is you're going to take 0.025 liters times 3 molar, and that's going to give you your number of moles. If you're not sure why that works, we'll show you the process a little bit later. With grams, we're going to take this molar number, and we're just going to use the molar mass of HCl to convert it from moles to grams, and we get 2.734 grams of HCl. For the last one, figuring out the molarity of the solution, we're going to take this 0.075 moles and we're going to divide it by 1 liter. 1 liter because we have 795 milliliters plus another 25 milliliters. That adds up to 1 liter. So the new molarity of the solution is 0.075 molar. We would say that this solution got diluted. Okay, so on the next slide here, I have just kind of a really broken down first question. How would I solve it? So let's take a look at it. You'll notice that the volume is 25 milliliters, molarity is 3 molar. Those are the 2 numbers we've been given at the start, and you'll notice here at the bottom our answer was 0.075 moles. How did we find that? Well, the problem here is that molarity, remember, is moles divided by liters, so I got to find some way to convert from milliliters into liters. In order to do that, I am using a conversion, which I show right over here. Yep, 25 milliliters divided by 1,000 milliliters multiplied by 1 liters. That's how you get 0.025 liters. You could also just move the decimal point 3 places to the left, and that does the same thing as divide by 1,000. It gets you the same answer. Also, do you like how I use different colors? Got a light blue over here for milliliters and then a dark blue over here for liters? I thought that was pretty cool. Go on. No? Okay, so anyways, moving on here, we've got to plug in stuff. 1 for molar. We don't plug in anything for moles because that's what we're solving. And then we can plug in that 0.025 liters for liters. Then it's just an issue of isolating moles. So we're going to multiply by 0.025 liters on either side, multiply them together, and that's how we get 0.075 moles. Now we're going to need to use that number for the next problem. So let's get after it. Second question is, how many grams of HCl are in the glass? So we know from the previous problem that 0.075 moles of HCl is what we have. So we need to convert it into grams. And like I said earlier, it's a molar mass thing. Here over on the side, I've shown you what the molar mass of HCl is and how I found it. The 1.01 and the 35.45, those are both numbers on the periodic table. So make sure you have those out. And when you do that, you get 2.73 grams of HCl. For question 3, asking about the molarity of the solution, we're going to do moles divided by liters. And we know here for liters that we have 25 milliliters plus 975. That adds up to 1,000 milliliters, same thing as 1 liter. So it's just 0.075 divided by 1, which is just 0.075. But now our unit is big capital N for molar. Or you could write down moles divided by liters as your unit if you wanted to. That's a pretty solid review of everything molarity. Let's jump into the lesson today. It's going to be very, very short, hopefully. Let's do it. Okay, so today we're talking about parts per million. This is another way to measure concentration. So if you don't measure it based on moles per liter, you could also measure it based on parts per million. Parts per million is best used for solutions that are very, very dilute. And so oftentimes it's used to measure pollution because pollution tends to be relatively dilute. You will never have more sulfur in the air than you have air, right? Unless you're like really, really polluted. But like if you're just measuring air quality stuff, that's how you would do it. Anyways, it describes, this is worth writing down, describes the number of grams in a 1 million gram solution. So when we're talking about numbers like 10 parts per million, that means if you were to take like 1 million grams of air, 10 of those grams would be sulfur. Now, 1 million grams of air is huge because air doesn't really weigh a whole lot, right? Or it could be 1 million grams of water, which would be the same thing as 1,000 kilograms, which is a ton. So if you take a ton of water, maybe a literal ton of water, you would have like maybe 5 grams of lead in that water or something like that. That could be a 5 part per million solution. So if you take 1 part per million of a year, fun fact, that's 31.6 seconds. So it's a half a minute, give or take. That's pretty cool, right? The maximum amount of fluoride allowed in your water supply is 4 parts per million. Compare that to toothpaste. Toothpaste has about 1,000 to 110, or sorry, 1,100 parts per million of fluoride per everything of toothpaste. So toothpaste is pretty concentrated, your water supply fairly dilute. Oh, and 4 parts per million is about 16 drops in a 55-gallon drum. So 16 drops, fun fact, is less than a milliliter. So really, really tiny amount in a really, really big drum. And then 0.015 parts per million of lead is the maximum allowed in water for it to be considered safe. That's also the same thing as 15 parts per billion. So oftentimes they'll measure lead not in parts per million, but in parts per billion. So we'll talk about parts per million. We'll also talk about parts per billion. Okay, let's get into the stuff that you actually need to know. Let's get into the formulas and stuff. So here's how you find the numbers. You're going to take your grams of solute divided by your grams of solution. Your grams of solute will usually be your pollutant, so like your lead, your sulfur, your fluoride. And then your grams of solution will be something like rock, air, water, whatever the entire thing is. Once you divide grams by grams, you're going to take whatever number that is and multiply it by 1 million. And then the units are PPM, parts per million. If we ask you to find a question with parts per billion, it's the same equation, grams of solute divided by grams of solution, except instead of multiplying it by 1 million and calling it parts per million, now you're multiplying that number by 10 to the 9th. You're multiplying it by billion, and then the units are PPB, parts per billion. Sound good? Great. Here are 3 sample problems. We'll go ahead and do the first one together. The first one says, 465 gram sample of rock has 4.56 milligrams of bismuth in it. And we're looking to calculate the parts per million of bismuth. So how you would do this is you'd take, well, first off, you got to convert milligrams into grams. So when you do that, you have to move the decimal place over 3 times or do this little conversion here, and you get 0.00456 grams of bismuth. Then go ahead and divide that by that 465 gram number. Once you've done that, you multiply it by 1 million, and you end up getting something like, I think it's 9.8 ppm, 9.8 parts per million of bismuth in that sample. Hey, go ahead and try these other 2 problems out. See how you do. Ready, set, go. Okay, so hopefully you've got those 2 problems done. Let's take a look at it. 56.8 gram sample of rock has 3.95 milligrams of bismuth in it. Here's how we would solve that. Same thing as before. First, convert milligrams to grams, and then divide those two numbers. Here you'll see I multiplied by 10 to the 6th. It's the same thing as a million. It's just a different number. And you get 69.5 ppm there. For the last problem, it is 1.06 ppm. Now for this last problem, I want to show you a little trick. You ready? This is the coolest thing I ever teach when it comes to parts per million. I was so hyped to teach this today. All right, here we go. So it turns out, this is kind of a shortcut here, that the units for solute will often be in milligrams, and the units for solution will either be in grams or even more often kilograms. So if you take milligrams of solute and you divide it by kilograms of solution, that gets you ppm. It just works, right? If you want to find milligrams of solute divided by kilograms of solute and then multiply that by 1,000, you get parts per billion right away. It just works. Now, the reason why it just works is let's take a trip back to unit 1 and look at the metric number line. You got kilo, hecta, deca, base, deci, centi, milli. This is our metric system, right? Now, if I assign each one of these guys a number, kilo would be 1 and milli would be 1 million. So the difference between a kilogram and a milligram is 1 million. So if you divide milli by kilo, there's a difference there of 1 million. So it just works with parts per million. So here's a problem right here. Hopefully now that you have that little strategy, you can solve it pretty quickly. Hope you solved it. Here's what I got. 1.3 milligrams divided by 2,500 kilograms equals 0.00052 parts per million. So really, really small number. We might even want to put this in parts per billion if we were to put this in a paper and publish it. You might put as 0.52 parts per billion. That might be how you publish it instead, just because it looks nicer. Now, if you didn't want to solve it this way, if you'd rather do it the old-fashioned way, convert both of these into grams, this is all the work you'd have to do. So I think you'll see that milligrams and kilograms can sometimes save you a little bit of time. Kind of cool, huh? Great. Here are two more percent by mass questions that we'll save for tomorrow. Get excited for the one that says your mom tells you that you're 1 in a million. If there's 7 billion people in the world, how many people are there just like you? I wrote that when I was in a dark place. But for now, I hope you guys have a great rest of your day. Can't wait to see you tomorrow to talk more about percent by mass. Take care. Bye.